Section 3.5, Local Linear Approximation. Let's kind of see a big picture of what we're going to be doing in this section, and then we'll do examples. Alright, let's suppose I have an x-axis, a y-axis, and I have some curve. Y is equal to f of x, okay? And let's pick some point x subscript to 0, and let's look at a tangent line to this curve at this particular x value. What's that tangent line going to look like? It's going to look something like that, right? Tangent line. Okay, so that's the tangent line to this curve at this particular x value. Now let's suppose I want to look at an x value just to the right of this x naught value, like right here, okay? Maybe that's an x value of, say, 4, okay? Or maybe it's 5 or whatever, I don't know. Let's say it's 4, okay? My function value at 4 is going to be right here. It's going to be the output of this function at 4, or we can say f of 4 is equal to 3. Now how about, instead of calculating that function value there, what if I were to, at 4, calculate the tangent line value there, okay? So what if I were to input 4 into the tangent line, m10 of 4, then I would get something that is what? About right there, a little less than 3. I would get something close to 3. Let me put this. Close to 3. And that's what we're going to be doing in this section. We're going to be looking at estimating the actual function value by using this tangent line, okay? Now why would we do something like that? It seems stupid. Well, sometimes our function is very, very complicated to calculate or whatever. So all we need is an estimation. So we use our tangent line because it is an actual line. So it's linear. So the calculation should be really easy and quick to get us at. So what are we doing? We're estimating the function value at a particular point by using the tangent line instead of the equation of the actual function here, okay? That's what we're going to be doing. Alright, so we call this local linear approximation. And your book reads this. It reads, for values of x near x naught, so values of x, like a value of 4, near this x naught value, we can approximate values of f of x by saying this. We're going to say f of x is about f at x naught plus f prime of x naught times x minus x naught. Now what is all that mess? That's just really the equation of the tangent line right there. This is local linear approximation. We need to know this formula. Well, that's really just the formula of the tangent line, because think about it. How do you find the equation of the tangent line? Y minus f at x naught is equal to m10 times x minus x naught, right? Well, what if I add f of x naught to both sides? I get y is equal to f at x naught plus m10 times x minus x naught. And couldn't I call m10 f prime at x naught? So m10, I'm calling f prime of x naught. Couldn't I call y f of x? And doesn't this look a whole lot like this form? Yes, except we have approximately because we're using that to approximate the actual curve value there. Alright, so know that formula. And let's look at some examples. First example is going to say, find a local linear approximation of f of x equal to square root of x at x naught is equal to 4. Alright, instead of writing all those in directions, I'm just going to write a, and I'm going to say f of x is the square root of x at x naught is equal to 4. Alright, so they want me to find a local linear approximation. So whenever they say find a local linear approximation, they want this. They want f of x is approximately f at x naught plus f prime at x naught times x minus x naught with this, and this filled in. Well, let's see. They give me the x naught value, right? They give me 4 for the x naught value. Let's find the f at x naught value. How do we do so? Well, just sub in 4 into your original function. Square root of 4 is 2. All right, so right now, what I have here is I have this value, f of x naught, we said was 2, plus I still need this, but I have x minus x naught, or x minus 4. So now I just need f prime at x naught. All right, they gave us f of x was the square root of x. Let's find f prime of x. Wouldn't that be 1/2 x to the negative 1/2? Or I could say f prime of x is equal to 1 over 2 square roots of x if I clean that up. But I want f prime at x naught. So I'm going to take this f prime, I'm going to evaluate it at x naught. So that means I write 1 over 2 times the square root of, instead of x, I'm putting in the x naught value, which is what? 4. So I'll give me 1 over 2 times 2, or 1 over 4. So that's f prime at x naught. I'm going to put that right here, 1 over 4. That's what they wanted for part A, the local linear approximation. Now you might be thinking, well, let's distribute 1/4 through here. You could, but you're going to see why in part B we do not do that. Part B. Part B says, use that local linear approximation to approximate the square root of 4.1. Approximate the square root of 4.1. Alright, so I'm going to use this. I'm going to use f of x is approximately 2 plus 1/4 times x minus 4. Now keep in mind, f of x is the square root of x, right? So what's replacing x here? 4.1 is replacing that x right there, right? So f at 4.1 is approximately 2 plus 1/4 times 4.1 minus 4 if I sub it in. Well, that's approximately 2 plus, let's see, what's that, a 10th. So, what does that give me? 0.025. So what does that give me? About 2.025 is my approximation of the square root of 4.1. Now, do you see how that comes in handy using that approximation? Because how else do you find the square root of 4.1 without a calculator? Well, you would ask yourself, what do I square to get 4.1? And you would probably try a bunch of trial and error. All right, let's look at C. Use part A to approximate the square root of 5. Use part A to approximate the square root of 5. So I'm going to use what I found here, my local linear approximation. F of x is approximately 2 plus 1/4 times x minus 4. And what is this 5 in place of in my original function? It's in place of x. So f of 5 is approximately 2 plus 1/4 times 5 minus 4. Well, what does that give you? 2 plus 1/4, or about 2.25. Now let's think about this for a second. Which answer is going to be more closer to the actual answer? Is 2.025 closer to the square root of 4.1? Or is 2.25 closer to the square root of 5? Think about what we're doing here, big picture, okay?